Okay, this video we are talking about applying sign chart method to solve a rational inequality. The first thing to do when we solve a rational inequality is to rewrite the inequality in the standard form. In the standard form of a rational inequality have 0 on one side. The other side you should see a rational expression or a rational function. We talk about the definition of a rational expression and a rational function in chapter 7, right? You see the top is a polynomial, bottom is a polynomial. The quotient of two polynomials is defined as a rational expression. So we let P R of x here, rational function. So we let R of x be x minus 6 all over 2x plus 1. Then the inequality would becomes R of x less than or equal to 0. So we are solving this inequality. And R of x is a rational function. Numerator x minus 6. Numerator has 1, 0, which is 6. Denominator 2x plus 1. Denominator has 1, 0 also. The 1, 0 is a negative half. Okay? And those two zeros, one is the 0 of the numerator. The other is the 0 of the denominator. Sometimes you have to factor the polynomial on the top, also factor the polynomial on the bottom in order to find their zeros. So what happened is, look at the rational function. Numerator is a polynomial, denominator is a polynomial. You factor both top and bottom to find the 0 or zeros for the top, also the 0 or zeros for the bottom, and put them together. In this case, we have 2 only. Those 2 zeros divide the whole real number line into 3 parts. This is negative half, this is 6. So we're going to have negative infinity to negative half, but open here. I'll explain why do we have open here. Why do we have a circle here? And then negative half to 6, but the 6 is included. We're going to have a solid dot here, and then 6 to positive infinity. Why do we include the 6, exclude negative half? Let me explain. Because if we plug in x equals 6, we would have left-hand side be 0. We would have a true statement. 0 less than or equal to 0 is a true statement. So that's the reason we include the 6. And why do we exclude the negative half? Because if we plug in x equals negative half, the denominator be 0. Would a denominator ever be 0? We know that's not possible, right? We know denominator could never be 0. That's undefined. So the function or the inequality is not defined at negative half at all. Of course, negative half is not a consideration for the solution. So that's the reason we have a hole here. Okay? So those 3 intervals are going to be my row 1 in the chart. My row 1 going to have 3 intervals, negative infinity to negative half open, negative half to 6, left open, right close. Very important, okay? And 6 to positive infinity. 6 is included. Row 2, testing point. Any convenient number would be okay. So this one I'm going to try negative 10. Here I'm going to try 0. Here I'm going to try positive 10. And row 3, R of x, which is a rational function. Numerator is x minus 6. Denominator is 2x plus 1. We are going to look at the sign of R of x at those testing points. Plug in negative 10. Numerator is negative. Denominator is negative. Negative over negative, we have a positive. We know that, right? For example, -1 over -2. You have a positive half, right? Yeah, a negative number divided by a negative number gives you a positive quotient. Plug in x equals 0. Numerator negative because 0 minus 6, you know, that's negative, right? We don't have to know the exact value. We only need to know the sign. Denominator positive. So a negative number divided by a positive number, we have a negative number. 10. Plug in x equals 10. Numerator positive. Denominator positive. A positive number divided by a positive number give us a positive number. Okay? So what are we looking for here? We are looking for the intervals. We are looking for the intervals over which the function r of x less than or equal to 0. Negative, negative. Okay, did we find it? -1/2 to 6, right? Yeah, so we found the solution set from the chart. Make a conclusion. Solution set of the original inequality is -1/2 to 6. Left open, right close. I explained earlier why do we have 6 included and -1/2 excluded. You can repeat the video and make sense of that. Last example of this section, number 6. We are solving this inequality, rational inequality. 2x minus 5 all over 3 minus x less than -1. Yes, this is also a rational inequality. However, this rational inequality is not in a standard form yet. It's not in a standard form yet because the right-hand side is not a 0. Be very careful, okay? Don't just go ahead and find the 0 for the top, which is 5 or 2, the 0 for the bottom, which is 3. Don't rush. You're gonna rewrite the inequality in a standard form first. In a standard form, we need a 0 on the right hand side. So we add a 1 to both sides. We have a 0 on the right hand side. Left hand side, we have 2x minus 5 all over 3 minus x plus 1. And let's combine those two terms. We copy the first rational expression and then rewrite a 1 as 3 minus x over 3 minus x. You see that, right? Numerator and the denominator are equal to each other, gives us 1. And now the two rational expressions have the same denominator. We can add them up. The denominator is 3 minus x. Numerator, we're going to add them up. We're going to solve the top. 2x minus 5 plus 3 minus x. Combine like terms, we have 2x minus x, that is x, -5 plus 3, -2. And when I look at this inequality, the left-hand side, I have x minus 2 on the top. I have 3 minus x on the bottom. So I want the bottom maybe be x minus 3. It's better, looks better, right? In a standard form of the polynomial, the linear polynomial. So what's the connection between x minus 3 and 3 minus x? They are opposite, okay? If I multiply this part by -1 and then multiply this part by -1, I have to flip the inequality symbol, right? I flip the inequality symbol to bigger than. And I would have this inequality in this form. Very, how do I say that, neat. Numerator is x minus 2, denominator is x minus 3, bigger than 0. This inequality is equivalent to the original inequality. Or we can say this inequality is the standard form of the original given inequality. We need the given inequality in the standard form, and then go ahead to apply the sign chart method. We let P of x be the left-hand side, x minus 2 over x minus 3. Numerator has 0, 2. Denominator has 0, 3. Those two zeros divide the whole real number line into three parts. Part 1, negative infinity to 2, open. Part 2, 2 to 3, open. Part 3, 3 to infinity, open. How come this time we do not include either 2 or 3? We exclude both, because the reason we don't include 3 because 3 would make the denominator be 0, right? Of course, we exclude 3. And how come we exclude 2 also? Because if you plug in x equals 2, you would have the left-hand side be 0, and then you have 0 bigger than 0. That's not a true statement. That's a contradiction, okay? That's a contradiction. So we exclude both. We exclude both. Then the 3 intervals we're gonna consider are all open intervals. Am I clear about that? Okay. So let's make the chart. I want a blue color. Row 1, 3 intervals. First interval, negative infinity to 2, open. Second interval, 2 to 3, open. Third interval, 3 to positive infinity, open. Row 2, testing point. From negative infinity to 2, I choose 0 because it's convenient, right? Yeah, from 2 to 3, unfortunately, we don't have an integer between 2 and 3. So I will have to try 1.5 or 3 over 2. And here I will do 10. Row 3, we look at the sign of the rational. Okay, sorry. I should use R of x. Yeah, R of x. R is the initial of the rational, right? X minus 2 over x minus 3. So let's see. The first testing point is 0. We plug in on the top, we have negative. Plug in the bottom, we have negative. Negative divided by negative, we have positive. Plug in x equals 3 over 2. The top is gonna be positive or negative? Negative. The bottom is gonna be hold on. 2 over 5. Yeah, my bad. Sorry. So here it's gonna be 2 over 5 over 2. 5 or 2, 2.5. 2.5 is between 2 and 3, okay? Yeah, so we plug in 5 or 2. We have a positive on the top, and then we have a negative on the bottom. Because 2.5 minus 2 is a positive. 2.5 minus 3 is a negative. So we have a negative here. And then we plug in x equals 10. Positive, positive, positive. And so what are we looking for? We are looking for the intervals over which R of x is a positive. We are looking for intervals over which R of x is a positive. Here we go. You see that? So the solution set of the inequality, rational inequality, is going to be the union of two intervals. The solution set is negative infinity to 2, open. Union 3 to positive infinity, open. Okay? Yeah, so this is a sign chart method for solving rational inequality. Okay, we have 3 parts. Remember, we have 3 parts for section 10.6. Yeah, shorter videos with a shorter duration in the YouTube, I believe, guaranteeing the quality. Earlier, I made a very long video, but turns out it was compressed. Okay, so this is section 10.6. Repeat the videos and make appointment if you have any questions in Zoom. I hope to see you soon in Zoom. Thank you for watching.